say today we are going to discuss about schema refinement. Schema refinement. What is schema refinement? What is schema, man? So schema means logical structure of database. Logical structure of database. See how we can write like our table is student. What is schema here? Our table is student. Student having student ID, name, gender. So these are the properties. This is called schema. It doesn't have any data. Just we are declaring table name and attributes. Okay. This is about schema, right? So schema refinement. Refinement means what? Refinement means what? Means purifying. Purifying. Say refinement means purifying. So you are purifying schema. How we can do it? See why we need to refinement here. Why I need to refine the database? Because of duplication. Because of duplication. Or we can say redundancy problem. Redundancy problem. Redundancy means what? Can anyone reply to me? Redundancy means? Redundancy means?
Duplicate data.
Duplicate data. So what is the problem in our database? So we have duplication. Duplication means what? Copy of the files. Copy of same copy. We are creating number of copies. Okay, because of that we are wasting our memory and we are getting confusion, right? Redundancy. So what type of redundancy available in our database? So like table level redundancy, next row level redundancy, column level redundancy, table level redundancy. See ma, here we have one file schema.txt file available in C drive. Available in C drive. The same file available in D drive also. This table level redundancy. We are creating copy of the tables in different drives. So this is one type of redundancy. Row level redundancy. Row level means see here I am creating one table called student table. Table student having student ID and name, ID something. Okay, see student ID 1, ID 2. name Siva. Next, student ID 1 whatever something. So see here, row level redundancy. See the row level redundancy. Another name, then 1 ID 1. See here, we have row level redundancy here. Row level redundancy. Are you finding row level redundancy? Control C. See, this is the row we have. Same row available in this table with the same data. So this is called what? This is what? Row level redundancy. This is what? Row level redundancy. Okay. Next, column level redundancy. Column level redundancy. See, if you have other column, the same column name available. So here available one and here also available one. So this is called column level redundancy. Okay. So we need to refine it. We need to refine how we can refine it. Okay, how we can how we can avoid redundancy. Okay, how we can minimize the redundancy problem. Okay, so to avoid this problem, we should use normalization concept. Normalization. We have some normal forms, so we need to follow the rules. Then we can avoid this redundancy problem. Okay. Table level redundancy, row level redundancy, column level redundancy. How we can do it? Through normalization. Next, this is about schema refinement. Okay, so we have concept like functional dependency, FD, functional dependency. So what is functional dependency? What is the use of it? So functional dependency means, see here, we have a table SID, SName. Okay, so CID, CNAME and P amount. See here some theory what we are going to discuss today in the schema. This is another concept. You think like this is third unit, the schema refinement and normalization. So schema refinement, how you can refine the schema means by using normalization. So what are the topics we are going to discuss here means in schema refinement and normalization. So first we need to discuss about schema refinement. Next, functional dependencies, reasoning for functional dependencies. Next, normal forms like first normal form, second normal form, third normal form, BCNF. Next, fourth normal form, fifth normal form, DKNF normal form, DK normal form. This we will discuss on the properties of decomposition. So this schema refinement we are how we are doing means by using decomposition. How we can decompose it? How we can decompose it? To do schema refine. Okay, with the normalization. So this we will discuss in this chapter. Okay, first is the schema refinement means. So schema refinement refers to refine the schema means so purifying our database, how it is cleaning the database by using some techniques. We are using some techniques to refine the schema. Okay, the best technique of schema refinement is decomposition. So we need to decompose it. Decompose it means what? we have one table, all the data available in one table. Okay, see here we have one table, student table having student data, course data, every data available in student table only. So there we need to decompose it. Decompose it means we need to write these two attributes in one table, and these two attributes in course table, and we these two attributes in one table. So we are decomposing one table into multiple tables. Okay, to avoid this redundancy problem. Okay, like table level redundancy, row level and column level redundancy problems we can overcome. Okay, that is what schema refinement. Okay, the normalization or schema refinement is a technique, okay, of organizing data into database. Okay, we are organizing data, we are maintaining data into database. How we are maintaining? So we have duplicate data. So through which technique we can recover that problem? By using normalization and schema refinement. How we can do schema refinement? By using normalization. Our normal form, first normal form, second normal form, third normal form. So by using that we can recover it. First, what is redundancy here? Redundancy refers to, see here, first normalization. So normalization or schema refinement is a technique of organizing data into the database. It is a systematic approach for decomposing tables. Decomposing tables. We are decomposing table. See, one table we are making one table into multiple tables. Okay, based on the conditions, based on the rules. So that means we are eliminating data redundancy. Because of decomposing tables, so we are eliminating the data redundancy and undesirable characteristics like insertion, while inserting, while updating, while deleting, anomalies. Anomaly means problem. While inserting we have problem, while updating we have problem. So deleting, while deleting we have the problem. What are the problems? We will see next. So insertion problem, updating problem and deletion problem. Anomalies means problems. So insertion problem, update problem and deletion. While we are inserting data, what is the problem? While updating data, what is the problem? While deleting the data, what is the problem? We will see here. Okay. See next, the redundancy refers to the repetition of same data. Repetition of same data. Redundancy means what? Repetition of same data or duplication of copies in the same data stored in the different locations. Different in C drive we are storing siva.txt file. In D drive we are saving same siva.txt file. So this is the repetition of duplicate copies we are maintaining in different places. So that is called redundancy. Okay. Next, anomalies. Anomalies refers to the problems. So anomalies means what? Here problem. The problems occurred after poorly planned and normalized databases. Okay, poorly means we are not taking care of about our databases, means about redundancy problems, so the data inconsistency problem. We have a lot of problems regarding the database. We are, if you are not planning to avoid this type of things, we have the we are not comfort with that, so we are not unable to handle that. So how we can manage it? So if you are poorly managing, poorly planning about normalization of the databases, so so that's not perfect. So if you want to be arrange the data in organized manner means, so we should follow the normalization concept. So where all the data is stored in one table. See how you are poorly planning the normalization means you are storing all the data in one table. Okay, one table. So which sometimes called a flat files database. So all data you are storing in one table. That means you are poorly planned about our database. Okay. So here anomalies means what? Problems occurred after poorly planned and normalized databases where all data is stored in one table. Okay, that means we are storing all data into one table. Okay, is sometimes called a flat files database, also called a flat file database. See, anomalies are problems facing without normalization. If you are not using normalization, okay, what are the problems with the redundancy? We will see here. Okay, see, anomalies refers to the problems occurred after poorly planned and unnormalized databases where all data stored in one table, which sometimes called the flat file database. Okay, let us consider schema, type of schema here. We have a database here on table, student table, having student IDs, name, and course ID, course name, and the fee. Okay, so here primary keys are student ID and course ID. Here all data is stored in single table. All data, course data and student data available in single table, which causes redundancy. Redundancy of data. Say anomalies. That is the problem. As SID and SNAME are repeated once for the same course ID. For single course ID, it is repeating. So S1 student name S1 and student ID here S1 redundancy there for single course ID, single course. Okay, for single course C1 have S1 and S1 two times duplicate. So this is the redundancy problem. For the same CID we have two different IDs, two same IDs. So let us discuss anomalies one by one. Here, due to redundancy of data, we have to get the following problems like insertion anomalies. While inserting, what is the problem? While redundant storage, update anomalies. While updating, what is the problem? So while inserting, what is the problem? See here. CID, C name. This is course name. See here, if you are trying to update course, first we will see the insertion problem. Okay, I'm inserting on new course, that is Python. Okay, Python course ID. I'm inserting Python, but for Python course, no students are available. No one taking Python course. So now here data is not. We are forcing to insert some other data, dummy data. So that is the insert problem here. Okay, if no student available for doing Python course, so what we are giving here, we are forcing to insert some dummy data. So that is called insert problem. Okay, so next thing is what? Insert problem, update problem. See, what is the insert problem? It may not possible to store some information unless some other information stored. So if you are inserting Python course, means you need to insert the SID SNAME also. So but SID name is not available, no student are available to take the Python course, so we are forcing to insert the dummy data. So that's what insert problem, insert anomalies. It may not possible to store some information unless some other information stored, so unless some other information stored, yeah, this is not possible to store some information. So that is called insertion anomalies. Insertion anomalies. Okay. Redundant storage is some information is stored repeatedly. Repeatedly, if you are trying to store same data, that's called a redundant storage. Redundant storage. Update anomalies. Update anomalies. See the update anomalies. If one copy of redundant data is updated, if one copy of redundant data is updated, here we have one copy, redundant data, duplicate data, redundant data, we are trying to update. Okay, we are trying to update redundant data. See what happened. Then inconsistency is created unless the redundant copies data is updated inconsistently. So if you are updating this value means c value means wherever c, that data also should be updated. If it is not updated means, so that is update problem. See here I am updating c to here I am updating C to some other data, R language, R language. So if I updated means here, if I updated means, so wherever if you update C value, that should be updated. Here also should come update. If you are unable to update these all values, that is update anomalies, update problem, update anomalies. That's what they explain. If one copy of redundant data is updated, then inconsistency is created. Inconsistency means the data is not available. Okay, unless all redundant copies of data are updated. Okay, next, deletion anomalies. Deletion anomalies. Whenever you are performing deletion operation, so what is the problem? It may not be possible to delete some information without losing some other information as well. See here, we have course table, right? Student table. So if you are deleting course C course, if you are trying to delete C course, so C course related student ID, student name, student information also going to be deleted. Okay, you are trying to delete course data, so course related data also will going to be deleted. This all data will be deleted. So that means what, you are losing student data also. If you deleted course data, you are losing student data. That is the problem of deletion. So it may not be possible to delete some information without losing some other information as well. Okay. Problems in updation anomaly. If there is updation fee from 5,000 to 7,000, then we have to update fee column in the rows, as data will become the inconsistency. So if you are trying to delete, you are trying to update the fee 5,000 to 7,000, we are trying to update 5,000 to 7k. So then we have to update fee column in all rows, you should update. So if I updated here, instead of 5k I updated 7k for this s1. So we should update for all other 5k. Wherever we have 5k, so there we need to store 7k. If you are unable to do that process, so else the data will become inconsistent. That means that is called inconsistent. We will have an inconsistent problem. Okay, have you understand? So this is the problem. If you update 5k here, so you should update Wherever we have 5k, we should update. If you are unable to update it, so that is the problem here. Insertion anomaly and deletion anomaly. These anomalies exist only due to the redundancy, otherwise they do not exist. Okay, redundancy problems. So because of redundancy, if you are trying to insert one data, or it should if the all students not taken that course, that means we are you are inserting some dummy data. Dummy data means that should be duplicate, right? See here. So dummy data we are inserting. While you are inserting Python course, you are inserting dummy data here. Every time you are inserting same data. So this is duplicate, right? That is duplicate. So because of that duplication, we have insert anomaly and deletion anomaly. Okay. Insert anomalies. A new course is introduced C4 here. See the examples. So new course is introduced C4. Course is introduced, new course, that is C4. But no student is there who is having C4 per subject. See here. Here course name we have C4, and for C4 no student is available. Then that's what insertion problem. So we have table here, SID, SNAME, CID, CNAME, CP. So we are trying to insert C2. So C2, we are inserting new course here. CA is a course, CA is ID, and course name is database, and fee is 12k. This data we are updating here, we are inserting. So that means what? But this course is not allocated to any other student. No students are taken this new course. Then the data will be null, right? Default data is what? Null. If you are not inserting any data, SID, SNAME, but what will be inside of that table? Null values. Default be null values are storing. So that means what? Instead of null, what if you want to perform any operations in the middle? So we need to store some dummy data into the table instead of null. So storing dummy data instead of null. So therefore it consists insert problem. See here, instead of null, I use it to store dummy data. Okay, to insert the row, it is required to put dummy data. That's what insertion anomaly. Okay, are you understanding? Yes, all of you.
Yes, sir.
See, we have table here. We have a table. So we have some data. These all are data, right? These all are data. So I'm going to insert a new row. I'm going to insert new row. This is new row now. This means in the new row, I'm going to insert course ID, course name, course fee. But I inserted DB is the new course. Okay. For taking DB course, there is no student available. There is no student available. There is no student available. So what should I do? That means Defaultly, while I am inserting this data, default values are what? Null values. Okay. Instead of null values, I'm trying to store some dummy data. Instead of null values, I'm storing some dummy data. So to insert that row, it is required to put dummy data. So making us to put dummy data. Okay, that's what insert problem. Because of that insertion some data, it is forcing insert some other dummy data. Next, coming to deletion anomaly. Deletion anomaly. So deletion of S3 student caused the deletion of course. See here we have the table. I'm trying to delete S1, S3. So student S3, I'm going to delete student S3 data. So student S3 row from the student table. So what is happening? If I deleted student data, means your course data also going to be deleted. So because of deletion of some data, forced to delete some other useful data. Understanding? If you are trying to delete the student information here, that course information also going to be deleted. The course information also be deleted. So that's what deletion anomaly. Some useful information also we are losing here. So that is the deletion problem, means deletion anomaly. The solution for to this what? Decomposition of the tables. That means schema refinement. Okay, decomposition of tables. We need to decompose it. Okay, example. So there are some anomalies in this again. So updation anomaly and the deletion anomaly. So if you are trying to delete one row, so that should affect on all the other rows. If you are not if you are not unable to do that process, that is update anomaly. See here, a student having no course enrolled, we have to put the dummy data. So we are putting all, so all anomalies we are performing in one table. So update and insert and delete. If you are trying to delete student information, it is going to delete course data also, course information also. We are inserting one data, that's some course data you are entering. Thus no students are not taking that course, so we are trying to insert um, some dummy data, that is insert problem. Okay, what is the solution? What is the solution? What is the solution for this? The solution is what? Decomposition. Decomposition table separating into number of tables. So decomposing into relations as shown in below. We are separating one table into number of tables here. See here we have student table. So I am separating, means I am decomposing the student table into multiple tables here. This is R1 table, or called R1 relation. This is R2 table or R2 relation. It's R3 table or R3 relation. See, we have, see here. mm, See here, this is one table, right? This is student table. This is student table. So student having student ID, student name. Okay. Next to course ID, course name, and fee also. This is all data available in one table. So we are performing decomposition operation to avoid that anomaly. You have problems, right, while inserting, while deleting, while updating. So to avoid that problems, we are following decomposition. Means what? So I am dividing this table into number of tables. Okay, I am decomposing. So first table name R1, R2, R3. So how I am dividing means, see, SID, S name in one table. SID, S name, one table. That table name is R1. So second table, SID, CID, SID, CID. So this what, second table. So R3 table, R3 table having CID, that means post table, C name and P. This is about another table. So how I can connect these two tables? By using R2 relation. So because this is primary key here, and from CID we have, from R3 table we have CID is primary. I am maintaining this is different table, separate table, and this is separate table, and this is separate table, this is separate table. Because of we are able to avoid anomaly problem from insert an anomaly, and update anomaly, delete anomaly. Are you understanding? So in this way we need to decompose it, okay, to avoid anomaly problem. Okay, from this table I divided into multiple tables, R1, R2, R3. So from student table you have student ID, student name, I divided. From course table you have a course ID, course name, P, divided. Then how can I provide the relation means? See here, I create another table, R2 table, that having family key here, SID and course ID. We are maintaining another table. Okay, right. To avoid redundancy and problems due to the redundancy, we use refinement technique called decomposition. What we used here, what is this process we call? This is called decomposition. This process is called decomposition. Decomposition. Okay, understand? Next, decomposition means what? Decomposition means the process of decomposing a larger relation into smaller relation. A larger relation means all the data available in only one table. So that table we are dividing in smaller tables. Okay, based on the data. Okay, so that is called decomposition. The process of decomposing a large relation into small relation, large table into small tables. Okay, one large table we are dividing into some small tables. That is called decomposition. Each of smaller relation contains subset of attributes of original relation. Subset of relation. See, this is large table, right? Big table. So subset of attributes we have SID, S name in this relation. Okay. In this R1 table we have SID, S name. So that is what here. Each of smaller relation contains subset of attributes from original relation. From original table we have some attributes in smaller table. Okay. So functional dependencies. See, next is what? Functional dependency. What is functional dependency? Okay. So how we can say that is functional dependency? Okay. So how we can do means, see the functional dependency theory here. The functional dependency is a relationship, okay, that exists when one attribute uniquely determines the another attribute. One attribute SID, yes, from student relationship. So from students relation we have attributes SID, S name. Okay, if you provide the relationship between the SID and S name, the uniquely determines So that is called functional dependency. Okay, if you are providing the relationship between attributes, the relationship between the attributes, that is called functional dependency. Okay, the functional dependency is a form of integrity constraint that can identify schema with the redundant storage problems and suggest refinement. How can I clear that problem? By using integrity constraints, you know, right? Primary key, foreign key. That means it doesn't allow the duplicate values or null values. Okay, it should be unique. This type of suggestions we can get by using integrity constraints. Okay, so functional dependency, see here, a tends to b, a stands to b. That means a determines b. That means what? B depends upon a. A is big table, and say a having big table, b having small table. That means it contains dependencies having a value, b value, some attributes we have here. So that means this b is depending on a. This b is depending on a. That means a determines b value. That means what? If I give a value, based on that a value, I can find the b value. So that means what? We have functional dependency. We have functional dependency. See one table here. X is by x having values data. I have written some data here. Here's x is a attribute and y is a attribute. Okay, so what is functional dependency? A tends to b, then x tends to y, tends to x tends to y. So that means what? X having one value, y having two values. So that means what? It is not satisfying functional dependency. See here, x having 2 and y having 2. So that means it's satisfying functional dependency. The functional here we have functional dependency. Okay, see the condition. That means what? Here x determines the y. That means y depends on x. Okay, y depends on x. First we need to check x value. If it is true, then we need to go for y value. We need to check y. Okay, if x is not true, then why I need to go for y value. So x stands y. X determines y value. That means y depends upon x value. See here, a functional dependency A tends to be in a relation holds true if two tuples having same value. Tuples having same value. If you have same values, then two tuples T1 and T2. If we here also 1. So two tuples having same values. Two tuples having same value, the functional dependency A tends to B is true. Okay, and also have the same value of the attribute with. So here A tends to be in a relation holds the true when it is going to true if two tuples having same value of the attribute A also have the same value of attribute B. So attribute A having one value 1 and attribute B having value 1, then it is called functional dependency. We can say it is achieving functional dependency. Okay, x attribute having 1. Okay, it is true. Then y value having 1. So that is true. So here we can maintain the x tends to 1. That means we can maintain functional dependency. So that is what meaning of this line. A functional dependency A tends to be in a relation holds true if two tuples having same value of attribute A and attribute B. Okay, so how we can do that one by using this formula. See here. See here, when we can say satisfying functional dependency, these attributes following functional dependency, if condition, if if condition, if t1 dot x means tuple 1 and tuple 2, t1 dot x equal to t2 dot x, t1 dot x equal to t2 dot x, t1 dot x value is what 1 equal to t2 dot x, t2 dot value is what t2 dot x 1. This is true. Then only we are going to check this t1 dot. Here t means what now? Tuples row. Okay, and t1 dot y, this is y attribute, right? From y attribute also t1 from tuple t1 dot y is what 1 equal to t2 dot y. From t2 row y is what 1. So that is also equal. That means what we can say, then x stands y, means x determines y value, y is depending on x. Okay, so to find whether we are following functional dependency or not, we should use this formula. First, if by using if condition, check whether it is true, then go to check other this. If both are true, then return true. That means it is in functional dependency. Okay, though the attributes having functional dependency. Okay, there is a dependency between the attributes. Okay, that means what? While you are performing functional dependency, the value should not be changed. Okay, if one attribute value here 1, that having the value 1 only, you should not change. P here 1, it should be here also 1. Otherwise, if it is contained 2, so value is different, so it returns false. That means what? It is not in functional dependency. Okay, there is no dependency between two attributes. So we need to use this formula whether to find there is a dependency between the attributes or not. Okay, okay, already time out. Okay, the remaining things we will see in the next class. Okay, try to understand this concept, the dependencies, redundancy problems, the schema refinement. So remaining topics we will see in the next class. Okay, thanks for listening this class. Now you can leave the